Hello, today is Saturday, July 4th, 2026. This is Curtis Herman in Agra, Oklahoma. I'm making this video for myself as much as anybody, maybe for my sons that might be working on this equipment later, or even my grandkids. Who knows, maybe I'll sell it, somebody will be interested. But this is the controller for my 4x8 CNC plasma table that I got from Plasma Route CNC back in 2008. It is not the original controller. I upgraded this, I think, in 2015. It was late November or early December in 2015. It was one of the very first CandCNC systems that Tom Cottle put out. I have had to do some repairs to it through the years, and I'm in the middle of a repair now, and I'm not completed. I wanted to make this video while I still had it a little bit opened up and could see some of the internal parts and kind of document some things. So there's the tub. It was all dirty. I've cleaned it up. I've had everything out of there. And there's the most control parts down here. Down here is the DTHC4 card, the Mesa 7992. Down there's the UBOB 3 and the peripheral. I don't remember the proper name for that card, and I don't know the proper name for this card. It's just a connector board. And we had, well, I'm going to say first, in 2021, we had a failure of the A axis. And technically the A is the slave on the Y, the second one. And it was this Gecko controller right here. We did the process of elimination and came up with the fact that this drive was bad. At the time, we didn't know whether it was this card right here that's bad, which is the Easy Plug Stepper 2 card, or was this, and I ordered both of them. When I ordered this card, I sent my original card back to CNC for them to test, and they tested it that it was still good, sent it back to me, so I have that as a spare. And I replaced this Gecko G201X drive back in 2021. You can see the little bit of difference in the coloring on them. Well, what happened was a few weeks ago, we had been using the plasma table. Everything was working just fine. I fired it up one day and was jogging it around, and I noticed that one side of the Y-axis was being lazy. It was not keeping up, and the motor wasn't energizing, and so only one side was pulling it back and forth. We tested it. We tested and found out that it was, this time, it was the Y-axis. So these two work together to drive the Y-axis. This is the A, the slave. This is the Y. This is the Z, and this is the X. And so we determined this time, and I kind of foolishly just assumed it was the Gecko again. I ordered another Gecko immediately from Maria's over at Gecko, which she sent out to me. When I got it, when it arrived, it was actually a G210X, which is a more sophisticated drive than those. It has the exact same footprint, the exact same functions. Everything works the same, and I did confirm that it is backwards compatible. I can use that here just fine. I have to have the dip switches set properly. This one has more capabilities than the 201, but it will kind of dumb down to replicate that. Samuel installed it when it got here, and it did not fix the problem. And so kind of surprised us that it didn't fix the problem. And so what Samuel did was Samuel stole the leads. There's power leads. So down here we got a toroidal transformer that takes it down from 115 down to, I think, 25 volts AC. And that 25 volts AC is fed into this UDCM, Universal DC module. And it outputs negative over here, positive over here. You can see several terminals, and the wires all come up here, and each one, even though these two steppers are on the same easy plug, they don't share the power input. Power input here, these two lines, negative and positive, is for this one. power input here for this one, this one, this one. Well, what Samuel did was he took these two wires loose, left them hanging. He took the Z axis, moved them over here, and the Y axis started working. He had that green 210X driver in here, but the Y axis started working. And so we assumed that the power output for those two wires was bad on the UDCM card. We'd never seen it. So Samuel and I took all this apart, and we dug this out, and we found that these inputs, or these outputs here, that input to this, are common. In other words, there's no distinction, no difference between any of them. That really threw us a curveball. We did check the continuity of the wires that came up here, thinking maybe there was a bad wire. Wasn't anything wrong with the wires. When we got the UDCM out, here's the original UDCM. You can look at the back of it, and you can see it's labeled 415, so it's April 15. That's 2015, so it's 11 years old. And we found that these two resistors are charred right there. You can see the heat damage on the board. You can see a little bit of a heat signature on the side of the fuse block. When you look below it, you can see the heat signature on that. And so it was starting to fail. It hadn't actually failed completely. And the theory is that the current draw was enough that when all the motors were trying to work together, that it was starving, and for some reason the Y-axis was the one that failed first, because that's the only logical explanation. So I ordered the board. The board was shipped on Thursday, July 2nd. Got here the next day, got here Friday, yesterday. And I took this all apart, cleaned all the dust out of it, cleaned everything up really good. And I found that the fan, this cooling fan, is completely cooked. You see that black center? It's not supposed to be black. It's supposed to be this color. That's a label, and that is burnt, right? So I can't even see the model number on the fan. I do know that it's a 12-volt fan. When I pull the fan blade out and the rotor out, I can look at the coils. I can definitely see that the coils are charred. When I tested it with a meter, it's open. So it had overheated so bad, and it finally gave up and burnt the coil up. So the cooling fan has been bad on it for who knows how long. And so that is what I would attribute the failure to, is that we got too hot inside here and it stressed that out. So I'm fixing to connect up power and test the input to that, the outputs to that, just test some basic before I cover that all up. And you know, the way I am, I've done my research now. This is all fresh in my mind, and later on I'll have a problem again and I'll forget. So I can go back and watch this video and hopefully it'll bring it back. I did find out this toroidal transformer down here, it has two outputs, and the other output is capped back there, not used. So if I ever had a problem, I could try to use that other output. I did take pictures of all of these things close up, the models, the specs, everything. This is the 5-volt power supply. The 5-volt power supply runs the fan, and then it runs this little white wire, and this is going to connect to the U-bob, and then the U-bob is going to daisy chain its 5 volts. So that's just connecting to the power for the motion control. Doesn't do anything for this stuff. And you know, down here, this is a whole nother story down here, right? The DTHC card provides the dynamic torque height control of the Z-axis. This is the 7992 card, the Mesa card, that gives us Ethernet connectivity, and the U-bob 3 down here, that's the universal breakout board. This one is the one that controls all the peripherals, so my limit switches, all of that kind of thing. The outputs for the auxiliary outputs is all connected down here. And anyway, this should be in good shape and ready to function. Like I said, I have a spare one of these cards now. I have a spare one of these, and I suppose it's possible I could replace those resistors. I probably wouldn't. It was only 100 and some bucks. It wasn't too bad. So anyways, soon I'll have this back together and working. Which this is the red table. The blue table uses pretty much the exact same controller. The only thing that's different is it uses a different set of drivers and cards there, but pretty much the same system.